Hello again, and welcome back. This is a review of the diagnostic test, page 21, and we're going to go over to questions 25, 26, and 27. So let's go to work. Question 25 says, which of the following is not a property of a binomial experiment? So right off the bat, I'm going to underline not. So that means out of the 5, 4 will be and 1 won't. So let's go ahead and list those requirements. Now, a little bit of review. Bins versus bits. So a binomial distribution requires bins. Those are the 4 standards. And bits would be a geometric. So that's how we keep them apart. So they're pretty much the same thing. Binomial means an outcome of only 2 different outcomes. Independent, in, both of them have a number of in, but we think of this T in a different way, and then the S reminds us of think about successes and failures. So these are the 4 qualifications, and I'm willing to bet one of these are each there and one of them is not. So when I'm looking for what's not there, I'm actually trying to look for this T. So when something is binomial versus something geometric, it's very, very similar. So I give the example of in a geometric distribution, it's pretty much the exact same, but I go looking for that item and I keep looking and looking and looking until I find one. So if I have a dice right here, I'm trying to get a 6, I just keep rolling, got a 4. Roll again, got a 3. Roll again, got a 6. So it took me 3 chances to get a 6 and I stopped. So the letter T reminds me the number of times or trials it took to get 1 6. Now if I rolled this 100 times and I just counted how many 6 I got out of 100 times, that's bins. Sounds exactly like the same experiment I did, but one I do and do and do until I get a success. This one, I just decide a fixed number of trials and then I count how many times I got what I consider a success. So when I look through these choices, D says a fixed number of trials. That's definitely a property. That's an in. What's the probability of success? That's this idea of S. The outcome of each trial can be classified as a success or failure. That's that idea of B. It's 2 results, success, failure. B binary means 2 results. And the probability of those 2 have to add up to just 1. And all trials are independent. That's I. So I've literally spelled out the word bins. So it looks like maybe E is my answer. The trial continues and continues until a success. The letter A connotes that 1. When you get 1 success, whatever that very first success is, you stop. So my answer is going to be E. Now let's proceed to the next question. 26. This is similar to one before. Jerome decides to take a simple random sample from a population that's normally distributed. However, sigma, which stands for the standard deviation of the population, is not known. That's very common. Oftentimes we do not know that. All is not lost. If we don't know that, we can use the standard deviation of the sample to approximate it using this formula we've used before. So the standard deviation, also we use the letter S sometimes. The standard deviation of the sample, or also known as S. S is equal to the standard deviation of the population over N. Very useful formula on our formula sheet. So when I look here, it looks like they want to use a sample size of 20. So I go ahead and say sigma over the square root of 20. Now as I glance through my choices, I'm seeing some things I can eliminate right off the bat. So I'm going to have no B, no D. Feeling good. Now I kind of decipher, using my formula sheet, these other components. It looks like this would be true if and only if it is a proportion question or I have an infinite number of samples. And so it looks like it's not a proportion question because of the word population mean. That word right there is the dead giveaway that it is not a categorical question, it's quantitative. So now I do have to mess with my degree of freedom, and I have to use table B in my book. So I'm going to flip to table B in my book, grab the phone so you guys can kind of see this table here. So table B, if n is 20, then my degree of freedom would be 19. I'm not allowed to scroll down here to infinity unless it's a proportion question or I have a whole bunch of numbers, and I don't. I only have 20. So I'm going to go to 19 degrees of freedom, and I'm going to keep going over in table B until I get to 95 confidence interval. Notice there's that number 1.96 in some of the other answer choices, but I'm not going to fall for their trap. I'm going to scoot up here, and I notice the number 2.093. So back to my question. That is my critical value I want, 2.093. So I have eliminated every choice except A. Next question. Question 27, Marvin is planning to use a simple random sample of 30 to estimate a population mean. So it's like the last question. What would be the margin of error? So again, using my formula sheet, I notice what is a population, what is a margin of error to estimate a population mean? Well, looking at my formula sheet, it says that a confidence interval is created. I'm going to use a sticky note for this. Confidence interval is created when I take the statistic plus or minus the critical value times the standard deviation of the statistics, which I think for ease, we're just going to call that S. I could call that sigma, but we'll just call it S, the standard deviation of the statistics. So the statistic plus or minus the critical value times the statistic. So it's now saying what would happen to the margin of error. So when I look at that, I kind of need to know what the margin of error is. So that's just both the critical value and the standard deviation of the sample multiplied together. So it was similar to the last problem. If I would have had and gone ahead and multiplied the critical value 2.093 times the standard deviation of the sample divided by the square root of 20, if I multiplied those two numbers, so if I would have gone ahead and multiplied those items, that would have been my margin of error. So let's add that to my notes. So they're asking me if I would if I would change my sample from 30 to 150, what would happen? So a lot of what's happening here is how S changes. So on the last problem, we said S is sigma over the square root of n. So if n is 30, then S would be sigma over the square root of 30. Correct? Now they're asking what would happen if now instead of n being 30, it's 100. So I'm just going to put the word versus because I'm looking, they're asking me to compare. Compare sigma over 30 versus or compared to sigma over 100. So we can approximate, we have no idea what the standard deviation of the population is, but let's just say it was 1. Kind of like our class, if I calculated the height of the room, plus or minus 1 inch. And let's see how the numbers would behave if we changed in. So if we just assume this is the number 1, what would happen if I take 1 over the square root of 30? So if I do that, I get 0.18. Then comparing this one, oh, excuse me, I wrote that under the wrong one, 0.18. Then if I take the number 1 divided by the square root of 100, that's 10. So 1 divided by 100 is 0.10. So notice, by increasing in, this number got lower. However, in the question, they didn't ask for 100. They asked for 150. So I could keep going with my analysis. I could say, okay, if I compared this sigma over the square root of 150, again, I'm assuming it's probably going to go down. So when I crunch that in the calculator, I get 0.08. So notice, as n goes up, the standard deviation of the sample goes down. That's choice B. It will decrease. And I'm going to stick my sticky note on there. Thanks for joining.